fucked up. Keep it weird.
Hi, I'm David Nascimento, co-founder and CTO of Mashed Potatoes. We build AI systems that combine creativity and engineering for media production and business intelligence. And Mashed Potatoes was born around AI. From day one, it wasn't a tool we experimented with on the side, it was central to how we thought about both creative production and operational systems. And over the past year, we've been working on several very different projects, but they all revolve around the same question. What happens when AI becomes part of the production pipeline? Not as demo, not as a novelty, as infrastructure. And at the beginning, our systems were fairly simple. Single-turn LLM chatbots and small automations. Prompt goes in, the response comes out, and some code glues the process together. But the technology didn't stay still, and thankfully, neither did we.
All right, Wendy Mark.
Like many teams experimenting with AI orchestration, we initially relied heavily on automation tools like NA10. And one of our internal experiments was a system we called Frank and Angelo. Its origin story is quite simple. Our creative director occasionally calls at 3 in the morning with extremely inspired ideas. And after a few of those calls, the CDO decided to see whether some of that brainstorming could be automated. So Frank and Angelo was an NA10 workflow designed to process client briefs and creative ideas. It would ingest a brief, generate potential creative directions, and then automatically debate those ideas between different LLM roles, copywriters proposing concepts and judge models evaluating and validating them. And structurally, it was a beautiful piece of workflow engineering. Slightly monstrous, but beautiful, and hence the name.
The AI agent revolution, which started with the launch and large-scale adoption of Microsoft Copilot, really gave us new ways to integrate AI into our production workflows in a useful, more autonomous way.
And experiments like Michelangelo taught us something important. As models improved, gaining reasoning capabilities, tool calling, and longer planning horizons, the limitation stopped being the models themselves. The limitation became the orchestration layer. We realized that we weren't building simple flows anymore, we were building systems that increasingly resembled agents. And systems that can plan tasks, call tools, iterate, and even evaluate their own results. And once AI becomes infrastructure, you're no longer just writing prompts. You're designing systems that must reason, execute, recover from failure, and remain aligned with real-world constraints. And here's something that nobody really warns you about when you start building AI agents. It's that traditional software is deterministic. If you call a function with the same input, you get the same output every time. That assumption is the foundation of software engineering. It's what makes testing possible, debugging possible, and systems trustworthy. Large language models are not deterministic at all. They are stochastic systems. Send the same prompt twice, and you'll often get slightly different answers. And usually, that difference is small. Sometimes it can even be useful. But once you start building agents, systems that make chains of decisions, those small variations stop being harmless. Decision A affects decision B, decision B reshapes the context for decision C. And very quickly, tiny differences start compounding. And after about 6 months of building agent systems, this became our biggest architectural takeaway. In our experience, and we suspect we're not alone in this, the hardest problem in applied AI right now is producing deterministic outcomes from fundamentally stochastic systems. And this isn't solved by switching to a better model. It's not a prompt engineering problem, at least for the kinds of systems that we've been building. It's an architectural problem. And let's look at the simple example. Imagine an agent like the one we've just discussed that is processing a client brief. It needs to extract themes, match those themes to visual styles, generate a production plan, and estimate timelines. Each of these steps involves an LLM call. Each call introduces a small amount of variance. Individually, that variance is manageable, but across an entire chain of reasoning, it compounds. Run the same brief twice, and you might get meaningfully different production plans. In a demo environment, this can actually be interesting, but in a production environment, it's totally unacceptable. A broadcast file cannot be almost the right frame rate, and a parser cannot mostly remember a client's budget. Business processes depend on reliability. So the real question stopped being, how do we make AI capable enough to perform the task? The real question became, how do we architect systems so that stochastic components still produce reliable outcomes? And that question really forced us to rethink how we design AI systems. And our answer to this, which is still evolving, is what we call the space gates architecture combined with radical atomization of agent work. And the core principle is simple. Big models plan, small models execute. When a complex task arrives, a large frontier model like Claude, GPT, or even in these days, Kimi, they act as the architect. Their role is to understand the intent of the task, break it down into the smallest meaningful units of work, and define success criteria for each step. Those small tasks are then executed by smaller models, often running locally, which also helps with protecting intellectual property and sensible data. These models are cheaper, faster, and significantly easier to constrain. And a small model performing a single well-defined operation is far more predictable than a large model attempting to solve everything at once. Between each step, we place what we call gates. Gates are validation checkpoints. Some are rule-based, some are model-based, many are hybrids. And every step must pass its gate before the workflow continues. If a result fails validation, the system retries or replans. And the key idea is that these gates are spaced throughout the process. You do not wait until the end of a workflow to verify results. You validate continuously. Think of it like quality control in a manufacturing line. If something goes wrong at station 3, you detect it at station 3, not at the final inspection. The goal is not to eliminate randomness. The goal is to contain it. And this architecture isn't theoretical for us. We're running it internally right now through an agent we call Spud. Spud lives inside our company's WhatsApp group, the same place where our team actually works day to day. And Spud is not a chatbot, it is an autonomous agent operating inside a gated architecture. It can read and write emails using its own account, analyze documents, access scheduling tools, browse the web, manage infrastructure tasks like DNS changes and deployments, and retrieve or store information in persistent memory. At the core of Spud is a heartbeat loop. The heartbeat allows the system to act autonomously, planning tasks, executing them, validating outputs, while still remaining within the constraint of the space gates architecture. Anything consequential still requires human approval. The human in the loop is simply another gate in the system. And Spud was initially spawned about 2 months ago and is gradually being integrated into our day-to-day processes. It already assists with real operational tasks and will eventually orchestrate many of our business and production workflows. In many ways, the story of Spud mirrors the story of our company. As the technology evolved, from chatbots to orchestrated systems to agents, our architecture, our methodology, and our way of thinking evolved with it. The biggest shift was really conceptual. We stopped asking, how do we get AI to do things, and started asking, how do we design systems that ensure AI behaves reliably? Mashed Potatoes is no longer just a studio using AI tools. We're really an AR architected studio. And the work we're doing today is not only about producing media or building intelligent systems. It's about designing the architectures that make those systems dependable in the real world. And what we realized is that building AI systems is ultimately about building the architecture of intention, structures that guide probabilistic models towards reliable outcomes. We're still figuring out where the bar really lies, but we think that this is the real question we should be asking right now. And a huge thank you to our good friends at iMatch and Building the Future for this opportunity to engage with you all. See ya!
Watched TV. It's all mixed up. Keep it weird.